Okay, Stacy and Julie asked if I would provide kind of an overview to this section that is mostly about restoration planning, at least a few of the talks. So that's what I'm going to endeavor to do, and what I'll present is really the result of work in collaboration with a bunch of different folks who are listed here. Dave Merrick from the Forest Service, Mark Briggs, World Wildlife Fund. Vanessa Beecham was a postdoc who worked with me now at Taos University, Ken Lair. I wasn't sure of his affiliation, so I put him down as the International Man of Mystery. And Mike Scott, colleague at USGS, and Anna Scher, who you're all familiar with. So we worked on, actually it was probably 5 or 6 years ago, on just putting together an overall template or process that we thought would be helpful in the context of planning restoration efforts in conjunction with Tamarix control efforts. So that's mostly what I'll describe, and we've kind of refined this a couple of times since the first iteration. I'll mention that the publications at the end of the talk. So the various rationales for controlling Tamarix that we're all familiar with, things like we want to control Tamarix in order to save water, to mitigate fire hazard, to improve wildlife habitat, to increase the proportion of native vegetation, things like that. But this link, this direct connection between Tamarix control and these rationales or goals is typically complicated by the fact that some other kind of vegetation is going to replace Tamarix in virtually all cases. So whether or not water savings accrue or fire hazard is mitigated and wildlife habitat improved really depends on what that replacement vegetation looks like. And as those of us who've worked around the West know, that there are all sorts of different trajectories for vegetation following Tamarix control. Some places might take a very long time to recover much plant cover at all. Other places could be restored to a nice, like this nice xeric grassland shrubland mix. This is a site that has converted to cottonwood forest in conjunction with management of stream flows. This is a site that's about 100% non-native herbaceous weeds. So there are lots of different possibilities. And that's where what we kind of all typically generically refer to as restoration principles. So we do quote restoration in order to try to influence what that replacement vegetation might look like. Just a quick definition of restoration, even though I think we all intuitively agree more or less on how we use that term, but the Society for Ecological Restoration defines it this way: the process of assisting the recovery of an ecosystem that's been degraded, damaged, or destroyed. Kind of narrow that down a little bit and just think about it as processes that assist the conversion of Tamarix to a type of vegetation that meets goals like those that we presented in those previous slides, things like wildlife habitat, etc. So as we were working on this group of us, we thought, again, that we wanted to first articulate a planning process for restoration of Tamarix invaded areas. It just seemed like historically, and things have really, I think, moved in a positive direction, but I venture to say that 10 years ago, there was a much greater percentage of the resource management and scientific community that sort of equated Tamarix control with restoration. There wasn't much else put into it. And certainly Tamarix control tended to just come first, and then thinking about how to influence replacement vegetation kind of came after the fact, which in many cases was too late and resulted in kind of an inefficient use of funds and other resources. So again, to encourage thinking beyond Tamarix control, to help resource managers identify what sorts of restoration activities are best suited for different kinds of sites. And then these last two I'm not going to go into as much, but this is sort of the research program that part of the research program that I've been a part of has tried to just improve our knowledge of these systems and understanding of physical processes, their interactions with riparian vegetation. Again, it's really encouraging to see the number of talks so far today that are really talking about the importance of hydrologic regimes, sediment regimes, and how those feedbacks between those driving physical processes are really important in understanding vegetation dynamics in these systems. So why plan? Well, again, it can improve, obviously, hopefully it can improve the probability of achieving goals that you might have. And, there's always the whole, negative, trying to avoid the negative. You don't want to have sort of an embarrassing failure in expenditure of hard-earned grant money by not doing a good job. So this is the process that we articulated. It's kind of a series of steps that moves from top to bottom, starting with goal identification, objective development, which kind of goes on in conjunction with evaluating ecological, non-ecological factors, prioritizing and selecting sites, and then developing a specific plan, implementing the plan, monitoring and maintenance, and engaging in adaptive management. And the rest of the talk will be running through these. And again, historically, a lot of times Tamarix control happened right at the top of this process. But we sort of suggest that it might occur down here. Now, with the biological control agent, we're kind of moving Tamarix control back up there anyway, so it throws a little wrench into the luxury of being able to really plan. There's still a number of projects out that occur that are on more discrete parcels where following this process could be done. And certainly the components that I'll talk about are applicable even in the context of biocontrol. Okay, so goal identification, we already talked about some of these. These are kind of the overarching reasons that you might want to control Tamarix or some other undesirable plant. Objectives tend to be a little more specific. So not only we want to improve wildlife habitat, and it might be a goal, an objective might be we want to establish 25 hectares of habitat dominated by 15 to 25 foot tall cottonwood willow. So that might be more of an objective. And a realistic objective is something like that might have some kind of boundaries on the size and the scope of the project. Not just we want to restore cottonwood willow to the entire Colorado River. Evaluating ecological factors. Again, we talked about that a little bit. I'm just going to run through some of these quickly. The site or reach scale evaluation, and this list, many of the components here are going to be the subject of the next couple of talks with some more detail put into how do we actually look at these things? How do you evaluate the geomorphic setting and the geological context of a river reach? And John Dornland and Bruce Orpold are going to elaborate on that. But these are just some of the key abiotic variables that are really important determinants of riparian vegetation. I'll talk about a little bit more. So again, a lot of these are hydrologic and geomorphologic in nature. There are a lot of biotic factors as well. So what are the local seed sources? What kind of seeds might be existing in the seed bank? What's the status of soil microorganisms or fungi? What's the condition of the extant vegetation, sort of the neighboring plants that are in the area? And importantly, what are the requirements and tolerances of different species that might be your targets for restoration? And that's where an area where we try to do some research to try to help provide information on some of these species that folks want to plant so that they know under what conditions they might do well. And that database has been growing. A number of folks have been working on that. Just that basic understanding of species tolerances is critical to helping to knowing what might be realistic in terms of planting at a given site. And again, this linkage between the physical environment and biotic conditions, i.e., how do vegetation dynamics relate to these physical processes? It's just an area that where the literature, the scientific literature, has really come into its own over about the last 20 years. So I would encourage folks to delve into that literature. And again, I'm encouraged that there's so much kind of reference to that now at this conference. Again, some of the main aspects of the abiotic environment. How do different species respond to different flood regimes, to different alluvial water table regimes, low flow regimes, soil salinity? And importantly, how are these likely to change in the future? That's kind of as a site evaluation tool that as we're, it's a little dicey and there's a lot of uncertainty around, as Jennifer alluded to, for instance, some of the predictions of future water supply in the Colorado River Basin, but it's something that we need to keep in mind in that situation that, I don't know, at least a few years ago, it was like 19 out of 20 climate models kind of were more or less in agreement on the general trend. So when you have pretty solid suggestions like that, it seems like it's worth paying attention to future conditions. There are a number of non-ecological factors that also can be really important determinants of what's a realistic and reasonable kind of objective. Things like site logistics, obviously how much money have you got for a particular program, and some of these others. What I find more and more too is that these stakeholder groups and processes that involve stakeholder groups and definitions, defining priorities and defining objectives is increasingly being done through those kinds of activities, and so that's really important, and it's more than it's just a lot more. It's more complex. It can be time consuming and challenging, but it's interesting. It really does represent more of an integration of social concerns and broader concerns than just resource managers or scientists working on river stuff. It's just something that seems to me to be increasing in importance and prevalence. So prioritizing, well, I mean, a lot of this is all pretty intuitive, right? Where once you've defined these objectives, where you have the best chance of meeting those objectives given all these various ecological and non-ecological constraints. So that's a pretty, of course. Now, how do you actually do that? I'm again going to just try to get you guys psyched up for the next couple of talks, because both John and Bruce are going to start to present some the makings of, and Bruce's sort of more developed tools to actually implement this at a larger scale. So how do you actually go about planning? How do you go about evaluating the fluvial processes, the hydrologic regime, and these factors that I've talked about being so important and that we all kind of understand are important, and make use that to help prioritize where you might do different kinds of restoration activities. One thing that seems to be a pretty common and again intuitive answer is that if places where you have natural processes pretty well intact, or where you might be able to actually restore some natural processes, are likely, should probably be prioritized because they're more likely to be successful in terms of restoration. Okay, implementation or creation of a plan. I'm going to kind of whiz through these last few steps. Included in a plan, though, I think it's important to consider monitoring. And this sort of is setting up these next several steps where we ultimately end up with adaptive management, the ability to try to use results from one project or one study to inform future ones. So if you don't set up in advance a decent monitoring plan and wherever possible, a pretty rigorous design, something that actually has an experimental design so that the results are not just anecdotal, then those results will be much more useful for future projects that you may do elsewhere or for other people. Again, different things to think about when actually putting together a plan, implementation, and then this post-project monitoring and maintenance. So this monitoring, focusing on variables most related to goals and objectives, that ought to be up there as well. So that ought to be thought about right from the start. And if you can have pre and post project monitoring, Anna had in some of her slides, she alluded to places where that they looked at where Tamarix was removed and other places where it wasn't removed, sort of that experimental control. It's trickier with biocontrol, but wherever possible, that's going to help you to improve future projects and help others as well. And typically, that's a little bit arbitrary, but it's at least what's important there is that it's not 1 to 2 years, which is kind of the typical. And we all know that it's hard to get money that far out, hard to get monitoring money in general. Okay, so the last step is adaptive management. So it's kind of taking the last few steps that I talked about, taking your monitoring data, taking the time to analyze and interpret those data, and use it to help improve future projects that you're going to work on, and hopefully articulate it and share it at meetings like this so that others can benefit. And it's pretty important, it's kind of in that flow chart, planning and prioritizing is pretty high up, but really, these things tend to loop around. So I consider sort of the adaptive management process as a planning tool if you think of future projects. So again, that's the flow chart. We've completely beaten the dead horse on this one and published it 3 times and will not happen again. They're different outlets, and so I guess that's it. I'm trying to get us back on schedule and leave time for the next few talks. So I'll take any questions. Yes? Do you want to start asking questions, right?
My question is simply, do you have examples of systems where this has been utilized, like a flow chart and model, a conceptual model that you could utilize?
Yeah, I think, and again, Bruce and John were one project where we're in the early stages of developing that. John's going to talk a little bit about one place where, since we published this paper, I'm just trying to think off the top of my head. I have received several emails from folks. I want to say there was and I can try to track down some specifics, but I remember somebody, for instance, from Glen Canyon Recreation Area saying, hey, we've been using this process and it's really helped us to develop restoration plans, et cetera. So there has been some pretty good positive feedback.
And the Dolores River Restoration Partnership actually used this model as the basis for their Dolores River Riparian Action Plan as well, and it's been really successful and a great planning tool.
Thanks, Stacey. She gets, I gotta buy her a beer now. She gets free beer though, because she's the press. Tamara?
I'm just going to suggest that you lengthen the post-implementation to 5 to 10 years, especially where passive restoration is involved, because I get in the 50 or so sites where we've worked in dinosaur, I could say several of them would have been declared failures if we made our call 5 years in.
Yeah.
But 10 years in with adaptive management, I would say it's successful. So I think people's expectations are often for instant gratification, and in areas where we really need to get people off that trap and instill patience.
Yeah, I think it's a great point. I kind of stumbled in, if you noticed, when I got to that part of the talk, because I thought it was, that's too short. And one way to think about that is, and it's not true of all the sites that are under consideration for quote restoration, but a lot of them are, a lot of the times the goal is cottonwood willow kind of communities, and those, from a number of studies, the sort of roughly the natural recruitment cycles around here are somewhere in the range of 5 to 10 years. So at a minimum, you want to allow enough time so that you might see a significant flood event or some significant kind of event, which, again, that's just one example of a recurrence interval for recruitment events on natural rivers. So that kind of is right in line with your suggestions. Okay, I got the hook. All right, thanks.